Right. Hello, and welcome to our project explanation of the code in Matlab systems. We made the song using Matlab, and we used a technique that is pretty common to make songs. We basically had just broken down the frequencies using values that we found through the internet to get certain notes and chords. Then we defined each duration, and we kept it at a 0.5 range of seconds, and then we made the melody, which was actually pretty fun to make. Once we had the melody done, all we needed to do was make a tempo and a beat duration, and the last thing we needed to do was to make the entire song and loop it. To do that, we made a for loop. We made the note duration, the frequency, and the song in general. We made a song file using this for loop. And once we did that, we had a final song, which you will hear now. So that was our song that we made using that system of for loops that we made. And now, once we had our song, all we needed to do was find certain values. And to do that, we got our plots and we made a bunch of them, such as a time domain representation, a frequency domain representation, and a spectrogram, which is this right here. Then we had to generate the white Gaussian noise, which Ishan will now take on.
All right. If you could go to the next figure.
Yeah.
So I just used a random function and multiplied it with the song as well. So just generated random frequencies, random noise, added it to the song, and then we got to the part of plotting. So this was our original song, and this is what it looked after we added the noise to it. This is, if you see the zoomed out version, initially we got a whole block, and then we had to choose a smaller time frame so that we could actually see the signal. And go to the next figure. This is the frequency domain representation of the same signal. As you can see, it has noise. You can check our report as well. It has a lot of noise, which will clear out in a second. Then, could you scroll up till here? And that's fine. We designed a low pass filter so that we used a Butterworth, I think it was called. I found it on the internet, but if you use that, it gets you the smoothest possible graph after removing the noise from the noisy signal. And it looked like this. It's not perfect, but I think it's better than the project we did in Control. So I was pretty happy with the result. And even for the frequency domain, the signal was a lot better than it was initially. Then we had the signal to noise ratio right here. So initially it was 16 in sounds, and while making sounds using Matlab, sound to noise ratio, as high it is, it's better if it's higher. So this was initially what it was, and then when we added the noise and then we filtered it out, it got way lower because there is obviously some error included, like we saw in the image before this. But we still have a good enough signal. You see, the signal isn't perfect, but that's why the sound to noise ratio is lower as well. That was our project for signals and systems. This was Ellie. I'm Ishan. Thank you for watching.